Building a network from scratch is very important for a network administrator and very important to the Network Plus certification. Here's the different topics we'll be covering: network topologies, managing power, and how to document those topologies in Power. Let's look at some network topologies. There's many different ways we can connect computing devices to our network. Network topology is a reference to the way we decide to do this, and there are certain standards that have been created over the years, and we can choose one of those or create our own. Each current standard has advantages and disadvantages such as speed, failover, or cost. And there's also completely different options when connecting WAN devices from connecting LAN devices. And that's because there's a lot of different hardware between two or more offices, and they're all going to be different in the way they connect. Let's start with the token ring developed by IBM, and it's generally used by computers for the ring topology. Many other components can also be made or acquired in a ring topology. The computers being arranged as the ring topology are not always arranged in a physical ring. They can be linked together, or they can be spread across an entire building. The main difference between an actual ring and a logical ring is the central connection that's responsible for connecting everything together. Whether it's physical or logical, there's still a circular topology. In the early days of office networks, you actually had a physical ring. There was a very thick type of cable called ThickNet that was brought all the way around a room, and then you had something called vampire taps that would cut into that rubber-coated ThickNet cable, and then it would go off to a BNC connected network interface card. The important thing is, don't break the ring. If the ring ever broke, meaning the ThickNet connection ever broke, then everybody would be broken. Eventually, the ThickNet connection was replaced by coax cable, and that was a little bit more flexible and easier to wrap around the room. But once again, if one connection was broken, then it was broken for everyone, and the ring failed. An advantage to all this is that it's easily deployed. You don't need a network switch. You don't need to configure a network switch. You just wrapped it around the room. No modern office is using ring topology anymore. It's just there for historical purposes and to be asked on the Network Plus certification test. The disadvantage, of course, is it's easily broken. IBM replaced the physical ring with a logical ring by coming up with a protocol called token ring. And basically, it didn't really matter how the computers were connected together as long as they stayed connected. A token would be passed around from computer to computer, and then whoever had the token was the one who could send data back and forth. Once that person was done sending data, it got passed on to another person, and that created a logical ring. Mesh topology is another one of these topologies that is rarely used, and it's because it's really expensive and it's very complicated. Every device needs to be connected to every other device. The good thing about this is that if you do have any connection that does get broken, it doesn't matter because you're connected to everyone in every other way possible, so you'll be able to continue to work. The advantage, of course, is total redundancy. The disadvantage is it's very expensive and very complicated to set up. You could say that the internet is a type of mesh. The data may also take several pathways to reach its final destination if the expected path is broken. And that's really why the internet was created initially, was because the government needed a way to launch nuclear weapons. And the telephone network is such a spider web that the government was confident that if any section got broken, they were still able to launch the nuclear weapons using the telephone system. They eventually gave up on that idea entirely and took the nuclear weapons off-grid because they were afraid of being hacked. And to this day, the only way to launch a nuclear weapon is to have it done locally. It cannot be done through the internet or through the phone lines, and the entire system is controlled by large floppy disks. The bus topology was used many years ago in networking, but is another one of these topologies that's not being used often these days. In this type of topology, the computers are all connected together and also to each other with the help of a single cable. What you see in the graphic below is not a switch at the bottom, it's just a logical grouping of computers that are physically connected to each other. Coax cables were connected using BNC connectors, and instead of using a ring, as was done previously, you could now put these in a bus or in a long line of computers because terminators were invented. So what would happen is, at the end of each of the cables, you could put a terminator at the end of your coax cable, and that way you did not have to have the ends connected to another device in a ring like you used to. Without those terminators, then it's just like a ring topology. It's broken and nobody can communicate with anyone. But as soon as you add a terminator, you can turn it into a bus, and then everyone will be able to connect without having to be connected in a giant ring. The advantage is it's inexpensive, definitely cheap to set this up, and the disadvantage is parts are difficult to find and easy to break. You're not going to find a lot of BNC type network interface cards anymore these days, and their parts are going to be expensive to replace, and it's very easy to break because everything sticks out along the back of the computer. So you could easily jam it against a wall or break it off with a trip of your foot. A lot of different things that could cause problems. And then once you took one person down, you took everybody down, similar to a ring topology. And now we have the star of the show, the star topology. It is the most popular LAN topology, and can be termed as a group of computers which are connected together with a central element, such as a network switch or hub. Now, of course, we don't use hubs anymore, but sometimes you might see one every now and then. I've had more than one customer find out that their network was slow because of an old hub that someone forgot to disconnect and replace with a switch. You can also put your star topology into an HA pair, or high availability, for redundancy. So instead of having a network switch in the middle, you'd have two network switches, and if one switch went down, the other switch would take care of the work. It's very easy to set up a star topology because you just put your network switch in the middle and connect all of your different computers and other devices all throughout the office. It's also easy to upgrade and easy to troubleshoot. If one connection goes down, it does not take down the rest of the office. The only disadvantage is you need a lot more cables. There needs to be a cable run from every different termination point where a computer or other endpoint is going to plug into it. And from there, it goes all the way back through the office and into the network switch. Now, once your internal office has all of its computers connected and safely set up in a star, then you got to think about the different types of connections out on the internet. And Frame Relay and MPLS are also using the star topology in that all clients link back to a central office. From there, they either connect to another office in the account or go out to the internet as requested by the user. The advantage to this is that it's centrally managed and very inexpensive. However, security-wise, the disadvantage is that the connection is being shared with other clients, although MPLS does give you a layer of encryption. Point-to-point is a direct connection between two or more offices. Sometimes you'll use what's called leased lines in order to connect those two offices. So basically, you're just renting the lines that are connected to each other. It's managed by the ISP, and the advantage is that it's completely secure and it's a private connection. The disadvantage is that it's really expensive, and not all locations are going to qualify, because if you have one ISP in one location and another ISP in another, there may be no way to get those two together. Point-to-multipoint is when one main location is connected to many other locations, but they're not connected necessarily to each other. It's also very similar to Frame Relay, but it's very expensive and difficult to qualify as it is for point-to-point. There's many other types of connections and topologies that are available, and the new ones, such as SD-WAN, are coming online every year. Managing your power in your on-premise network is very important because you want to make sure that even if you have a power outage, your computers and servers still stay running. A common power redundancy option is a UPS, or uninterruptible power supply. So if you lose power, you're going to have a brownout or a power surge, but the UPS can keep everything up and running by providing a battery backup. There's generally three different categories of a UPS. One of them is an offline or standby. That's going to only switch over to the battery if you lose main power. This is the simplest and most common type of UPS. It's also the least expensive. Cutover on this is the least predictable and can more easily fail. There's also a line interactive UPS that can slowly bring power up from the battery, which is really useful if you happen to have a brownout. It's also useful in areas where brownouts are more common than blackouts. Then we have the online option. This is one where you're always running from the battery. So if you lose power, there's no switchover needed. You'll simply continue to use that battery until the power is back up. It's the most useful, but it's also the most expensive. It also causes battery failure more often because they're constantly being used. It does, however, have the best results. Generators are great if you have an extended outage. A UPS will only work for an hour or so in most cases. So generators can be very reliable if you maintain them, and they come in many different options for what powers them. The disadvantages are that they are the most expensive option. You're still going to need a UPS to protect against brownouts and power spikes, and they tend to require maintenance and repairs a lot over time. The most difficult thing is that they have to be fine-tuned to the UPS. So by default, they will cut over during an outage, but the equipment that they protect tends to shut down and restart when that happens. By having an electrician fine-tune them to the same frequency as the UPS, then it will stay running while the generator is turning on if it's capable of responding fast enough. Documentation is very important to network troubleshooting. The problem you have today may have shown up in the past, and good documentation can help you solve it much more quickly. A physical network map is very important to documenting your network. A lot of times people will use the product Visio, as we're going to demonstrate today. Another option would be OmniGraffle for a Mac, or Lucidchart or other open source options. Visio is a paid program from Microsoft. There's many different types of diagrams that you can also create. You can create physical and virtual maps. A physical map is easy. That is the map of the physical devices that you have. But a virtual map is a little bit more difficult because it's conceptual. So for instance, if you have a pair of SQL servers in high availability, it's easy to show that physically. But how those SQL servers are serving up an application, that's a little bit more difficult to show on a map, but it's also equally important. You'll also want to have a ticketing system. Ticketing systems are great because a staff member will call in or send you an email saying that they have an issue. You'll fill out a ticket, and it provides several different purposes. The first thing is it shows your boss that you're doing something, which helps justify your job. Another is it gives the client, in this case the staff member, peace of mind that someone's actually doing something because you're updating the ticket, and the client can then see what it is that you're doing. And the third thing is, I find the most important, and that is if the issue comes up again in the future, then you can just search for it by keywords, and then you'll know what you did to fix it the second time around, and that will help you fix things much more quickly. A couple of options you can use for ticketing is a wiki or SharePoint, but you can also use other paid programs such as ConnectWise and other CRM programs. Let's do a demonstration of how to create a Visio diagram of a new network. We're at the Visio startup screen, and we're going to create a basic network diagram. So let's type in network here, or we can just click on the network link. So if you don't see the template you want, you can search for it. And we have the options for basic, detailed, and lots of other types of diagrams as well. And even a logical diagram such as Active Directory, something that doesn't show physical network devices, but is still very important so you know how your network is set up. Let's click on a basic network diagram, and we have the option for creating a blank one or using in some pre-filled information to make it go a little faster. I'm going to choose a blank one in this case because we're going to create a brand new one from scratch. And we see on the left-hand side several different network and peripheral devices for which we can grab and move forward. We also see computers and monitors, quick shapes, and if we click on more shapes, then we see all of the different shapes that we can use. And we're using Visio 2019 Professional. I like to start out my network with the center of a star topology, which is the network switch. Now, as I drag this out, you can see lines appear, so now I have it directly in the center of our diagram. Let's also put out a firewall, and we'll make it a little bit smaller. There we go. And we'll put out a network printer. Let's go up to computers and monitors, and we're going to bring out a PC. And back in network and peripherals, we'll bring out a server. So I realize that we have multiple PCs, so what we can do is we can copy and paste those PCs, and if you put them into a grouping together like this, it just means that you have a network of PCs. So you don't have to necessarily put out every single individual PC as far as their information. Now what we're going to do is we're going to tie all these together. So if we line them up so everything is working, we can select all of these 3 computers at once, and we can choose to group them together. So that way when we move them as a single unit. And now we've lined them up, and we're ready to make some changes. So let's go ahead and double click on our group of computers, and we'll put in Windows 10 PCs. And they're running on DHCP. And you can put any other pertinent information that you'd like at that point. Now I'm going to go down to our server and type in AD server, so it's an Active Directory server, and it's going to be statically set to 10.1.1.10/8. And we'll put some more information. Our domain name, we'll just put in test.internal. And we'll say it's a Windows 2019 server. And it's running DHCP, DNS, Active Directory, and file shares. So now we know what that server does. Now we'll go to our printer, and we'll say network printer HP. I'm just going to make up a series here, 2000. IP address is 10.1.1.200/8. And then we'll go to our switch. And we'll say it's a Cisco 2000 series switch. And it's going to be 10.1.1.201. And then we've got our firewall. Let's put in 10.1.1.1/8. And we'll say it's a Cisco ASA 5506X. And now we'll connect everything together. So let's click on Connector Tool. There we go. And now they're all connected. If we go to Design, we click on Connectors, and we can change the way the connectors work. So, for instance, we can make this a curved line, and then we can move it over here. That way it doesn't block anything. So we'll do the same thing here. And now we need to add in the cloud. So I did a search which goes out to the internet to find additional shapes that may not be there. And we found a cloud, so we'll just go ahead and grab this cloud. And of course the cloud is too big, so we're going to make it smaller. So we're going to double click on the cloud, and we're going to say ISP, and we'll put in a public address, 2.2.2.2. There we go. And we're going to double click on our firewall once again. We're going to add in the public IP address as well. So I can go over to Insert, Text Box. I can put in IP address, go back to our pointer tool, and I can move it down a little bit. So now our firewall has both an inside and outside IP address. We'll connect those together. And it's a little bit difficult to see because of the light blue everywhere, so if we want, we can change it to have something that has maybe better contrast. That's a little better. You can go to the background, set up a background. There we go. And now you can insert any other information that you'd like about your network and save it. And now you've got a basic hardware network diagram. We covered network topologies, showed you managing power and the different types of UPSs that are out there, talked about documentation, and showed you a demonstration of a Visio network diagram. Be sure you're familiar with all these concepts as you work towards your Network Plus certification.